When a building moves from an idea to a physical structure, the primary way a designer communicates with the tradespeople on site is through a drawing. If that drawing is flat, visually ambiguous, or poorly scaled, the construction team has to guess your intentions. On a job site, guessing translates directly into physical mistakes, wasted materials, and thousands of dollars in rework. To translate an idea accurately, you need a specific set of drafting tools. At a minimum, this includes A3 layout paper, a 3-sided architectural scale ruler, and a set of specialized technical fineliner pens that won't bleed on the page. Whether you choose to draw by hand or use digital 2D CAD software, which stands for Computer-Aided Design, a program used to create precise 2D drawings and 3D models, the underlying architectural conventions and ordering principles remain identical. By mastering these universal rules, you elevate your work. You stop making confusing, flat sketches and start producing precise, trade-ready instructions. Step 1 is establishing the parameters of your drawing space. Every professional draft begins with a contained border, a title block in the corner for project data, and a clear north point compass to show geographic orientation. Next, we use a 3-sided scale ruler. This tool allows us to mathematically reduce real-world dimensions into workable lengths on a piece of paper. If we use the 1:100 scale side and draw a line to the 9.5 mark, we have accurately represented a 9.5-meter wall. You should never start a draft directly in ink. Layouts require constant tweaking, so it's best to establish your rough proportions, zones, and basic geometry in pencil first. If you attempt to draw a 9-meter wall at a 1:1 ratio without converting it, your drawing will immediately run off the page. Scale confusion completely breaks the usability of the plan. Applying a mathematically accurate scale is the core mechanism of drafting. It is exactly what anchors your 2-dimensional page to physical reality. Once your layout is penciled to scale, we apply the cut rule. A floor plan is essentially a horizontal slice through a building, usually taken at 4 feet above the floor. The cut rule clearly separates the elements the plane physically slices through from the objects that sit below it. This chart shows a strict line-weight hierarchy. We assign the thickest lines to the load-bearing framing and exterior walls. Next, medium lines are used for fixed features like stairs. Finally, fine lines indicate movable objects like furniture. We also need to map out elements that aren't physically cut, but exist above or below the plane. Things like ceiling bulkheads or overhead kitchen cabinetry are drawn using a superfine dashed or dotted line. As you refine the heavy cut walls, you must draw accurate subassemblies. This means breaking down a thick wall into its individual physical components, like the internal stud frame, the thermal break space, and the exterior cladding. By strictly adhering to this precise line weight system, your drawing instantly transforms from a flat schematic into a clear 3-dimensional hierarchy of structural importance. Now that the structural boundaries are defined, we have to indicate the internal makeup of those materials. We do this using standardized architectural hatching. For example, you can use a solid black fill, known as a poché, to indicate basic exterior walls, or you can use intersecting lines and stipple patterns to denote specific materials like brickwork or concrete. If you are working digitally, there is a CAD equivalent to hatching called screening. By assigning a transparency percentage to your pen weights, like a 40% screen, you can create soft shadows and material textures that don't overpower the main structural line work. Next, we add our annotations. The strict professional rule here is to mandate the use of clear sans serif fonts, written entirely in capital letters. You must avoid any pseudo-hand-lettered font styles, as they reduce legibility for the contractor. To prevent visual clutter, you need a safe method for adding measurement dimensions. If you are drawing by hand, do this on a separate tracing paper overlay. If you are drafting digitally, place your dimensions on a dedicated toggled CAD layer that can be turned off when needed. Standardizing your material patterns and segregating your annotations and dimensions eliminates ambiguity. It allows the tradespeople to look at the page and instantly read the required assembly materials. Look at the completed drafted floor plan. It is accurately scaled, perfectly geographically oriented, and packed with clear structural data. To verify that you have successfully executed the visual hierarchy, you can use a practical tool known as the squint test. If your hierarchy is correct, squinting your eyes will cause the lighter annotations, furniture lines, and material hatches to fade smoothly into the background, while the heavy, load-bearing walls clearly stand out. Now that you have these fundamental drafting principles down, you can apply them to all your other technical outputs, such as exterior elevations or precise cross-section details. Maintaining strict graphic conventions takes practice, but it is the only way an architect can guarantee that their design leaves the page and is built exactly as intended.